I'm going to show you the complete setup for the lab. We'll start here. This is the motion detector. It's going to be able to sense the position of our cart with all the mass. Since it will then send that information to our computer where we have Logger Pro set up. As the cart moves, the motion detector will sense the position of our cart, and since it can know the time, it will graph on the top graph the position versus time, then calculate and graph the velocity versus time. From that graph, we can calculate, by using slope, the acceleration of our cart. So our cart is then attached to the string. Here's the string that goes over the pulley to the pan. The pan, which currently has a mass of 50 grams, will take extra mass. Here's the cart that has lots of mass on it. The mass on the right is just holding the cart in place. So the cart is attached to our string, which goes over a pulley, which is attached to the pan. And of course, on the pan, we can add mass from the cart and put it onto the pan. In this set of experiments, we're going to keep the total mass of the system, the total mass of what's being pulled, constant. So let's figure out what that total mass is. I'm going to take the cart and its masses, place it on the balance. Here's what your data sheet will look like before you start the lab. In the first column, you'll record your masses that are on the string in grams. In the second column, you'll convert that to kilograms, of course by dividing by 1,000. And in the third column, you'll need to calculate the force that the string is pulling on our cart. To do that, you'll need to use the force of gravity equals the mass, which is the mass on the pan, times little g, which of course is 9.8 newtons per kilogram. In the final column, the acceleration column, you'll record the acceleration that we get by determining the slope of the velocity graph. You can see here what the total mass is. 1928 grams, so 1.928 kilograms. This is run number 1. The slope of the velocity graph is 0.2599. Taking 10 grams, this is run number 2. The slope is 0.3211. I'm going to take a 20 and we're going to put it on here, and I'm going to put the 10 back over here. Run number 3. The slope of run number 3, 0.3708. Taking 10 and adding it. So now we have 50, 60, 70, 80. The slope of this one is 0.4459. I'm going to take a 20, put it on, and take off a 10. So now we have 90 grams. The slope on this run is 0.4780. I'm going to take a 10 and add it on. Now we have 100 grams. The slope on this run is 0.5604. I'm going to take off all of this 50, replace it with a 50, so I'm back to where I started, and now add 10 more. So I'm at 110 grams. The slope on this one is 0.5976. I'm going to take 20 and put it on here and take off 10. So now we're up to 120. Select that portion. Slope on this one, 0.6506. I'm going to add 10 more. Now we're at 130. Slope for this run is 0.7377. I'm taking off 10 and putting on 20. So now we should be at 140. Slope on this one is 0.7776. This is our last run. I'm going to add 10 grams. So now we're up to 150. And the slope on this last run is 0.8271. In case you missed any of the data points, here's what you should have. In order to calculate your force column, remember, you'll need to take your mass in kilograms and use that in our expression, the force due to gravity equals mass times little g, or the mass in kilograms times 9.8. And that's what you'll record in the force column. Finally, when you make your graph, you'll be using your force, which is what the pan and its mass is pulling on the string, versus, that's on your x-axis, and acceleration, which is what we measured, is going to be on your y-axis. And the results of that graph will help answer our question. What is the effect of force on acceleration?